Hello, students. Good morning. Good morning. Okay, so for this week, okay, we will be discussing on chapter 2, database system. Okay, but this chapter will be divided into two. So we will discuss this week and next week. But next week is Chinese New Year, right? So we don't have lecture next week. We will need to do replacement for the holiday. I will check your schedule first, and then I will let you know which uh, what date we can do the replacement. But I believe there are other subject as well for you to do replacement. But definitely we'll do the replacement maybe after CNY or during the CNY. Okay, I mean within the 1 month of your senior celebration, we'll do the replacement. But we'll see how it goes. Because in week 5, we will be face to face. Even though we are doing face to face already, we still can do replacement online. Okay, so I'll see my schedule and your schedule as well. See where we can fit the replacement class. It can be Saturday as well. Are you okay with Saturday? I may ask. Okay. So I'll see how it goes first. Definitely not next week. The replacement will not be done next week. We will be still doing our practical next week. So for this chapter, we will continue in the following week. Week 1, week 2, week 4. Okay, so the part 2 for this chapter 2 we will cover in week 4. Okay, so I will get back to you on the replacement class. Okay, and also for your practical, I forgot to publish the submission for practical one. So maybe you thought you don't have to do it. Okay, it's my mistake. I did not post. I already do the draft, but I did not notice. I did not publish it in your Google Classroom. So maybe you thought don't have to do it. Okay, but you need to do it. That's the homework for practical one because it's you will continue your output from the scripts from your practical one. You will use for this week's practical. Okay, so if we finish early today because we only have 20 slides for today, so if we finish early later, I think you can use the time remaining to do your practical one. Okay, so I really want you to do the practical one so that you can understand, or you can try on the scripts all are ready for you already. You can copy paste or you can type line by line. I prefer you to type it because you need to understand what are those lines means. Okay, so please do your submission of practical one before your next practical session. Okay, so can we start the lecture? Okay, so I will start recording. All right, so this is BSS 3183 Advanced Database Management, Chapter 2, the data on discussing on database system. This is part 1. Okay, so first let's look at the learning outcomes. Okay, learning outcomes. So the first one will be explaining the characteristic that distinguish database approach from the traditional approach. Okay, so we'll discuss on how traditional approach is done. Okay, so basically how the previous system or previous database system was done before we have this database approach. Okay, the modern approach of database. So this one, it's the programming with data files. So we'll discuss this in detail. We'll also have an example for this example of overview of how traditional approach look like. Yeah, and then we will also describe the basic functions and components of DBMS, the characteristic of DBMS, and what are the components that we have in DBMS. So the second part of this lecture, we will be discussing this in week 4. So we have this ANC Spark three-level architecture. We'll discuss this in the next part, and also the meaning of logical and physical data independence, and also differentiate among the various DBMS architectures. Okay, so these are the learning outcomes for this chapter for part 1 and part 2. Right, so for today, I think we only cover until here. Right, so now let's look at the first one, these advantages of file processing. So file processing here is referring to the traditional approach. Okay, traditional approach before we have the database system. Right, so it's referring on the program data dependence. So we will discuss this in detail in the next slide. So here about this dependence, program data dependence, all program that all programs will maintain the metadata for each file they use. Okay, so each program will have their own metadata. They will it will maintain each file that the program use. So we'll discuss that in detail after this. And then we have data redundancy. Also, we'll discuss this in detail. We, so the redundancy here is referring to duplication of data, where the different system or programs can have separate copies of the same data. Okay, redundancy, we look at this after this in detail. So several disadvantages that associated with this conventional processing systems are listed. These first two we will discuss in detail. So we also have this limited data sharing. So what is this limited data sharing? So with this traditional file processing approach, each application will have its own private files. Okay, so users will have little opportunity to share data outside their own applications. Means there is limitation for data sharing with other users in the system. And then lengthy of development times. So this one referring to a with this traditional file processing system, each new application, it requires that the developer essentially start from scratch by designing new file formats and description. So it, this developer will write the file access logic for each new program. Means every time there is a requirement to write to have a new file processing, the developer will need to design it from scratch, need to design a new file format, new description for each new program that is required to be implemented. So it will use um, long development times. Okay, so the last disadvantage would be excessive program maintenance. So here, the preceding factors of all combine to create a heavy program maintenance load in the organization if they rely on this traditional approach. In fact, as much as 80% of the total information systems development budget, it might be devoted only for program maintenance. Okay, so 80% of the budget of the organization for information system, they spend on maintenance. Okay, so this in turn will means that resources like time, people, and money are not being spent on developing new application, but to do the maintenance. Okay, so let's look at how this actually let's look at one example on this traditional approach. Okay, so let's look at this. So um, this is an example. So we call this file processing system. This system. This system is a traditional approach of file processing. So we have three departments here. We have order department, counting department, and also payroll department. Okay, so each department has their own program, right? So we in orders department we have program A, program B, and program C. Department accounting we have program AB, and payroll accounting payroll department we have program AB as well. So this file processing system, it only met the data processing needs for individual department. Okay, so these are the file processing, so it only meet the data processing need for this particular department. Okay, rather than the overall needs of this organization. So every file processing system only refers to its own department. So the information system group will only respond to user requests for new system by developing new computer programs for individual applications. So it can be like inventory control, account receivable, under payroll department, and so on. Okay, so these three of the computer application based on this file processing approach shown in this figure. So it here the system are order filing system. So we have three file processing system. The first one is order filing system, and then we have invoicing system, and the third one is payroll system. Okay, so each major data file here associated with each application. So um, here are the files, okay, associated with the file processing. So file here is referring to the collection of related records. Okay, so we have customer master file, inventory master file, and so on under each file processing system. Okay, so let's look at one example. Here we have order filing system has three files. Under it, we have customer master file, inventory master file, back order file. So notice here, we notice here there is a duplication of some of the files that used by these three file processing system. The one that is highlighted here is this customer master file. Okay, it's the same file, but it's a duplicate data and the order filing system. It also um, it also used in invoicing system in another department. So this is very common, or very it's a typical situation when you are using file processing system. Okay, so these two, this will definitely like fulfill the disadvantages, all these disadvantages of this file processing system. Okay, so we will look at here. You can see it is all these all these disadvantages can be seen in this system, file processing system. So let's look at the first the first problem, which is problem with data dependency. Okay, so each application programmer, they must maintain their own data, and each application program needs to include code for metadata of each file inside for each processing file processing system. And then each application program, they must have its own routine, like reading, inserting, updating, and deleting data. So means each application program. So for each of the file processing system, they must have its own processing routine. All right, and then lack of coordination, and there is no central control. Okay, we'll discuss this more. And there will be non-standard file formats under this problem. So we take again the example just now. So file description are stored within each database application program that access a given file. So means all this file here, the file description will be stored in this system, right? So let's look at one example here, invoicing system. Okay, let's look at this invoicing system here. So we have program A. Okay, so we have program A accessing the inventory pricing file and also the customer master file. Okay, so because the program contains a detailed file description for this file, so any change to a file structure will require changes to the file description for all programs that access the file. So it means if there's any changes happen here, you must also update at the main program. Okay, you must update the file description to where the file structure will be accessed. Okay, so means program A also need to update, program B also need to be updated. So now notice that the customer master file that is used in this order filing system here, customer master file, right? So suppose it is, let's take an example of in this customer master file, you need to change. Okay, you decided to change or update the customer address field length. Okay, so let's take an example of the customer address field length in the record in this particular file from 30 character. Okay, you just set previously the bar chart 30, for example. So now you want to change or you want to update it into from 30 to 40 characters. Okay, so the file description in each program that is affected, which is up to, it can be up to 5 programs, would have been modified. Okay, so means you need to modify program A, program B, program C, program A, program B. Yeah, so you need to update or the program affected with the changes that you made here, those accessing the same file, right? So it is difficult to locate all the program that is affected by these changes that you made. It's almost impossible to locate. Okay, so what can happen is that errors can happen when you make such changes with the occurrence of data dependency. Okay, so this is where this data dependency and the file processing system can affect your file processing system. Okay, the traditional processing system. So this one is for data dependency. Next, let's look at problems with data redundancy. Okay, so it is a waste of space to have duplicate data, and it can cause more maintenance headache as well. So the biggest problem would be when data changes in one file, it can cause inconsistencies in the system, and it can also compromises data integrity. Okay, so still in the same, you're using the same example. So let's take an example of order filing system here, right? It contains the inventory master file. Okay, inventory master file. And then in the invoicing system, yeah, the invoicing system contains the inventory pricing file, right? So this file contains data that describe this company product, like the product description, the unit price, and quantity that they have in hand or in the how many stock they have in hand. All right, so this can be this is a type of duplication whereby you have the same uh, data, you have the same data at different system. So this duplication, it can be wasteful because it will require additional storage space, and there will be increased effort to keep all files up to date. Okay, so if you change here, you also need to change here. All right, so data format, it can be inconsistent. The data value may not agree, or it can be both as well. Data format is inconsistent and data value is not valid, right? So reliable metadata are very difficult to establish in this type of system. Okay, in file processing system, it is very hard to establish a reliable metadata. Like for example, the same data item, they may have different names in different file, or the same name may be used for different data items in different files, but it's referring to the same thing. Okay, so that's why data redundancy is very common in file processing system. Okay, we take five before you continue to the second part. Okay, take five. Okay, can we continue? You can use the raise hand button. Okay, thank you so much. Okay, so we continue on the second part, database management system (DBMS). We will look at the characteristic of DBMS. All right, so the definition given here for software system, this is DBMS is a software system that enables users to define, okay, to create, maintain, and control access to the database. All right, so for database applications, under this DBMS, we have database application. So database application is an application program that is used to perform the series of database activities under this DBMS, which can be create, read, update, and delete. So those are the general activities that you do with DBMS. Okay. So here in this figure here, the central system is DBMS. So from end user, you access to web browser, and then from end user request for application, request for data, right? So they can be a view of data, it can be single, it can be integrated. So this is the database structure usually. So this is just an example. So in a database structure, you can have the metadata, the end user data. So in this case, you have customer data, the invoice data, and also product data. Okay, so in your assignment, you should also have all these. You should also discuss on the database structure of the organization that you pick for your assignment. All right. So this is the basic definition of DBMS. So what are the function of a DBMS? All right. So the primary purpose of a DBMS, it is to provide a systematic method to create. Okay, it can be create, it can be store, updating, and also to retrieve the data that is stored in a database. So it will enable end user and application programmers to share data, and they can enable data to be shared among multiple applications rather than propagate and stored in new files for every new application like the file processing system. So this DBMS, it can help with it has this concurrency control services, right? So DBMS, it also provide this facility for controlling data access. It also enforce data integrity, managing this concurrency control service, and also restoring database. Okay, so because of database is a shared resource, so the DBA, right, the DBA or the database administrator, they must expect and plan for the likelihood that several users will attempt to access and manipulate data at the same time, right? So with this concurrent processing, which involves update. Okay, so a database that has that don't apply this concurrency control, they can be compromised due to interference between users. Okay, so we will look at one example where it can error can happen when there is no concurrency control, right? So here are the solution for this concurrency problem, like if there's any interference between users. So in DBMS, you can have this locking, okay, locking, which is a pessimistic approach in DBMS. involving locking and also two-phase locking. You can also apply time stamping and also optimistic approach, which is versioning. Sorry, versioning. So every DBMS will support this concurrency control to make sure your end result is always accurate, even though there is an update made to the database simultaneously. The end result will always be accurate uh, for because we have this concurrency control service. So now let's look at what is the effect when there is no concurrency control in our database. Okay, so the most common problem that encountered when multiple users attempt to update a database without this concurrency control is loss of update. Okay, so figure here it shows a common situation where we have two-person here. We have John and Marsha. They have this joint account. Okay, they have this joint account, so both of them want to withdraw some cash at the same time, similar time, each using ATM machine in a different location. Okay, so let's say for example John goes for an outstation. John go to KL, for example, and Marsha is at KK. Okay, so they have this joint account, so they will be accessing this same account at the same time at different location. Okay, so let's look at this figure here. It shows the sequence of events that might occur in absence of concurrency control mechanism, right? So this is the timestamp. So John's transaction, okay, John made the John do the first attempt, the first event, which is reach the account balance. Okay, so John read the account balance. So here, during this time, the balance is still $1,000. Okay, and then he proceeds to withdraw $200. Okay, so before the transaction writes the new account balance, which is $100, Marsha transaction reached the account balance with which is still 1,000 because here the withdrawal from John's side has not happened yet. So at Marsha's side, she still can see the balance is $1,000. Okay, and then what happened? Then Marsha then withdraw $300. Okay, Marsha withdraw $300, which leave a balance of $700. So this her transaction write this account balance, which replaces the one that is written by John's transaction. Okay, so it overwrite this one, but the effect of John's update has been lost due to the interference between the transaction makes there is an error at the bank side. Okay, so the end user might not see the error, but at the bank side they will get the error. Okay, so this is just an example of a scenario when there is no concurrency control. All right, so this always happen when there is an event happens to the same database at different locations. So we'll also have another example later on airline system. Okay, so next we look at the next function of DBMS. So backup and recovery service under for DBMS. So in case of any crash, fire, or natural disaster, there will be this backup and recovery service so that the data will not be permanently lost. So database recovery, it's a mechanism for restoring a database quickly and accurately after loss or damage. Okay, so databases, it can be damage or lost or become unavailable because of some system problems that may caused by maybe human error. It can be human error, it can be hardware failure, it can be incorrect or invalid data, it can be program errors, computer viruses, it can be network failures, or maybe conflicting transaction like just now, and it can also be natural catastrophes. Yeah, so it can be natural disaster as well. So the responsibility here is on the DBA, the database administrator. So the DBA is to ensure that all critical data in your database are protected and can be recovered in event of loss. Okay, so because an organization will depend heavily on its databases, the DBA usually will have the responsibility to minimize downtime and other disruption while a database is being backed up or recovered. So usually to achieve these objectives, a database management system, a DBMS, must provide the mechanism of backing up data with as little disruption of production time as possible, and they able to restore a database, okay, can be restore a database they can restore database quickly and accurately if there is an event of loss or damage. Okay, so here in this figure you can see a database management system. They can have this transaction. We also have this term transaction in the BMS. They should have recovery action. They should have this backup. Okay, so usually database backup usually happen after working hour. Okay, so if you are responsible with the database server, so usually you will set the backup. Okay, the backup usually off office hours, so that's why your server must be on all 24 hours. Okay, so a DBMS usually they provide backup facilities that can produce a backup copy, okay, backup copy of the entire databases. It can also include control files as well as the journals. So each DBMS normally provides a copy, COPI utility. The command is copy for this purpose. So in addition to the database file, the backup facility also create a copy of related database objects. Okay, so it includes a system catalog. Okay, so we will discuss on system catalog after this. The database indexes, the source libraries, and so forth. So typically, backup copy is produced at least once per day. As I mentioned just now, it usually happen. You usually schedule a backup after office hour to ensure that all the data that has been updated for that particular day is backed up. Okay, so usually the copy should be stored in a secured location where it is protected from loss or damage. So this backup copy, okay, this backup copy will be used to restore the database in any event of the hardware failure, the catastrophic loss, or any damage that can happen to your actual database. Okay, so that's why this one need to be done at least once per day. Okay, so this is backup and recovery services. Next is security. Okay, so security here, DBMS also provides security. So what is database security? So it is a protection of uh, database data against accidental or intentional loss, destruction, or misuse. Okay, so as the database environment has grown more complex, so with distributed databases located on usually on client server architecture, uh, and PC as well as on mainframe. So access to data has become more open through the internet, right? Through the internet and also corporate intranets, okay, through intranet as well. And it can be from, you can also access your DBMS from mobile computing devices. So as a result of this access, so this the security that is applied on this DBMS, it can manage data security effectively, um, but it has become more difficult and time consuming. So because data in our database are critical resource, all the person in any organization, they must be sensitive to the security threats, right? And they need to take measures to protect the data within their domains. Okay, so previously I believe all of you have taken the security subject. Okay, so it's similar to that. So it's similar with database security. So database security is only as good as the security of the whole computing environment. It can be physical security, it can be logical security or change control of security. Then it must be established across all the components of the client server environment. Okay, so in this case, the client will be the user or usually the DBA. The server environment is referring to the database server. So this will include database server, client workstation, the network, okay, and its related components, and also the end user that's accessing the database. So here are some of the security component that you can apply to your DBMS: encryption, authentication, authorization, and also views. Okay, so I believe all these are familiar to you. So applying an encryption, okay, so this is an example of a column encryption, Dde column encryption in Oracle database. Okay, so applying encryption of data can help so that attackers will not be able to read the data packet that is being transmitted in the network. All right. So in addition to that, we can also apply authentication. Okay, authentication. So usually for authentication of the client workstation will be applied where when they attempt to access the server, the user or the client workstation need to be authenticated before they can be given the access to the database server. Okay, and for application authentication, we also have application authentication. This will give the user confidence that the server is being contacted, the server that is being used or being logged onto is the real server that is needed by the end user. And another one is audit trails of attempted access can help administrator to identify unauthorized attempts to use the system. Okay, so audit trails we already discussed last week, so you can refer back to our previous lecture on audit trails. So here the TDE column encryption, this one is specifically for Oracle database, so which we use for this course. So this TDE column encryption is used to protect confidential data such as credit card numbers. Yeah. So and it can also be the social security number, which is stored in this table column, right? So this TDE column encryption, it uses two-tier key-based architecture. So it uses key architecture authentication, encryption, and it transparently encrypt and decrypt sensitive table column. Like for example, this column is sensitive, it will use this TDE master encryption key to encrypt and decrypt to be used for the encryption and encryption of the credit card number here. Okay, so this one is for Oracle database. So you can have more read on this in the PDF that I shared to you. So you can search Dde Column Encryption in Oracle documentation. Okay, so this is for security. And then next we have the integrity services. Okay, so integrity services here is referring to avoiding incorrect or inconsistent data by complying set of rules. Okay, so in DBMS we can set general constraint in our scripts to ensure data integrity is enforced in our database. Right, so let's look at this example here. So here is create table. So this script is for you to create table. The name is property for rent, and then the property number is 5 character. Baca must be, it cannot be null. Okay, means not null here is referring to you this this field here, it cannot be empty. Okay, not null. This is one of the rules that is applied here. You must they this field here must not be empty. All right, similar to rent number and then staff number. And then we have this constraint. Okay, so constraint is typically for Oracle or SQL. So the constraint will check on this all these condition. Okay, so it selects staff number from property for rent group by staff number having count all more than 100. Okay, so this is an example of script in SQL for us to apply the integrity in this particular database. Okay, you also set the primary key to be property number, and the foreign key is the staff number with reference to staff. Okay, so in your practical one, okay, I think we will finish early this lecture. So I want you, those who have not done it yet, please go and check the practical one exercise. It's also create table. So try to understand each line of the script. Okay. So this is an example on how we want to avoid incorrect or inconsistent data by applying this set of rules like not now, you set the constraint, you check, you set the primary key, and you set the foreign key. Okay, so there are some types of integrity constraint in Oracle. Okay, so uh, this one is actually referring to a relational data model which includes several types of constraint or rules that is limiting acceptable values and action, whose purpose is to facilitate maintaining the accuracy and integrity of data in the database. Okay, so typically it's referring to this one now. Okay, the constraint that you set in your script. Okay, so the first one is not null. Okay, it prohibits a database value from being null. It cannot be null. Okay, it can be empty. Okay, in layman term, it's not empty. Okay, so but in Oracle we use the word null. And then the next one is unique. A constraint, it prohibits multiple rows from having the same values in the same column or any combination of columns, but allows some values to be null. Okay, so this one is for unique. This is another constraint or in Oracle. It prohibits there must be no multiple rows having the same value in the same column. Okay, but they can be combination of columns that and they can be some values that that can be null. Okay, it can be empty. All right. So next one is primary key. So primary key constraints, it combines a not null constraint and a unique constraint in a single declaration. Means in one script, you for primary key, you combine the not null constraint and a unique constraint in one single declaration. And then we have foreign key. For foreign key, it requires values in one table to match values in another table. Okay, so for our practical this week, we will look into this. I think we will cover all these constraint. We have this physical design or logical design of the database, and we will identify the foreign key and also the primary key. Okay, so foreign key usually is for you to have a value that can match with another value in another table. Okay, so foreign key can be primary key at another table in your database. And then we also have check. Okay, a check constraint. This constraint it requires a value in the database to comply with specified condition. Okay, so an example would be check the supplier ID must be between 100 and 999. It can also be the supplier name in, okay, must have these words IBM, Microsoft, Nvidia. It can also be like for you to check status, okay, the field name status. It's not in, cannot in these letters A, B, C, D. Okay, the previous one got cut. Okay, so here we have one check here. Okay, you check not exist, select staff number from this table. Group you must group by staff number having count all. Asterisk usually refers to all. It must be more than 100. Okay, so this is an example of check constraint. So here are the types of integrity constraint in Oracle that you might want to use. You can use all this. You maybe you want to use this in your assignment. You can do that as well. But mostly you will use it for you to create your database. Okay, so this integrity constraint also referring to the required data, what are the domain constraint, the entity integrity, the referential integrity, as well as the general constraints of your database. Okay, so there's another example here. So we have create table for all the detail, and then all the detail key, it's not null, and then other key, so not null usually this one, if it's not null, usually it's the primary key. Okay, notice here. Usually, if it's not null, usually it's the primary key. And then quantity number, it's number, and the length is 3. You must check the quantity must be more or equal to 1. Okay, so here also we have the constraint integrity, and then we have price charge number. So we have two field here, 6 and 2. It must check the price charge must be more than 0. Okay, it must be more than 0. So these are the constraint for check constraint. And then another constraint here, this order to audit unique. Okay, the unique, the order key and also the product key, and we have the primary key must be the order detail key. The foreign key is the order key with reference to another table. Okay, with reference to another table, which is customer order. This customer order must also exist in your database so that this particular table can refer to this table for its order key. And also another foreign key here, product key with reference to another table in your database, which is the product key as the usually this one is the foreign key, or it can be the primary key as well. Okay, so this is just an example on how you deal with integrity constraint. Okay, so far so good. Is everyone okay? Okay. Mhm. We take five. Okay, take five. We proceed to the next one. Mm, six, six slides. Okay, 5 minutes break, then you continue. Thank you. Okay, can we continue? Use the raise hand button. Okay, thank you so much. Okay. Okay, so we continue. I think this is the last part of this lecture. So we'll have more time to for you to do the practical. Okay. So hold on, so we have another function of Dbms here. It's transaction support. Okay, transaction support. So by default, most database connection assume that you would like to commit the result of executing query to database immediately, right? So it is possible to define the notion of the business transaction in your program with using this transaction support in DBMS. So what this transaction support is that it ensure that all the updates are made or that none of them is made. Okay, so it's referring to like one database. You want to ensure that all database updates are being made. Okay, so given that there might be thousands of users simultaneously trying to access or update a database, usually if it's through a web application at a given point of time. So we have an airline transaction here, for example. So the application developers, they need to be well versed in the concept of database transaction, and they need to use them appropriately when they are developing this application. So let's take this airline transaction example. Okay, so common transaction that will happen to any airline system is that there are many simultaneous users. So they can determine the departure and return flight records, right? And then they can update. They will this the airline transaction example, it will update seats remaining of departure flight record if there is selection of departure record before that. Okay, and then update seat remaining of return flight record after the database has been updated by the user, and you insert the reservation record into the database, and also you print ticket if requested. Okay, so this is just an example of how airline transaction can happen in a database system. Okay, so um, repeat. Okay, so first, what happened is you begin the transaction. Okay, you access the system, access the database system, and then there will be a greeting, and then you get reservation preferences from user, like the date, the time, when you want to use the service, when you want to fly, when you want to return, and then the user will select departure and return flight records. And then if the reservation is acceptable, then the system should be updating the seat, uh, the remaining of departure flight record, update the seat remaining of the return flight record, and it insert the reservation record. So if you notice here, these are always database DBMS function for you for you to include in your application. Okay, so and then bring ticket and if. Okay, so we have if here. So rollback is usually for us to if there's error, you can like undo. Okay, you can undo the process. Okay, so rollback is similar to undo command. So if any error occurs, all changes will be deleted from the database. Okay, so on error here is a part of exception handling. And now, so this is an example for you to see how this transaction support can happen in a database system according to the application that is used. So this in this case is airline transaction. Okay, so I think this one should be easy for you to understand. It's very straightforward. So basically, it refers to database that is being accessed by many people at one time. So it also related to data redundancy, data dependency, the one the ATM machine just now, the between John and Marsha. It's also similar to that situation, but this one is typically for this one is called transaction. Okay, in SQL. So next we still have another function of DBMS. So this is system. Sorry. So this is a user accessible system catalog. So in Oracle, in SQL, we have this system catalog, also known as data dictionary management. Okay, so this is an integral part of DBMS, which is the data dictionary, which stores the metadata. Remember metadata that we discussed last week. Okay, metadata which describe the data in the database. Okay, so this data dictionary is usually part of this system catalog that is generated for each database that we have. Okay, so this system catalog describes all database objects, including table related data such as table names, all right, the table creators or owner, the column name, the data types, the foreign keys, the primary keys, the index files, the authorized users, the user privilege, and so forth. Okay, so here it stores all these kind of objects, right? It also include constraints, the usage statistic as well. Okay, so this system catalog it is created and maintained automatically by Dbms. Okay, it's automatically means when you install your database it's already there. Okay, so it's for you to use that. Okay, so the information is stored in system tables which may be queried in the same manner as any other data table. But of course, the user that want to query to this system catalog, they must have sufficient access privilege to the database. Okay, so I repeat for system catalog, it's the repository of information which include the metadata of your data inside the database. So it typically stores database objects like all of these names, types, and sizes of data items, constraint of your data, names of authorized users, uh, level of access, and the usage statistics. Okay, so this is a system catalog. The next here shows you the system catalog that is provided by the DBMS before performing almost every action. Okay, so this system catalog here or the dictionary, it authorizes users, it process queries, it check integrity, etc. All right. So here, as you can see, we have the users, the DBS staff, database administrator, the casual user, the application programmers, or we can also have parametric users. Yeah, so every time they have all this access to the database system. So every time there is a query, usually query to this system catalog or data dictionary, it will access this particular system catalog. All right. So this is just to show you how this system catalog is being used. So it all usually happen almost every action that is done to your database. Okay, so DDL here stands for data definition language. And so this one is just very straightforward, just to show you how this DBMS checks with system catalog every time there's query from the users. Okay, you notice here everyone is referring to the system catalog, all the users. So DBS staff, casual users, application programmer, and also the parametric users, which with respect to this DML compiler. Okay, so this is an overview of Oracle system. And then we have this sample of Oracle catalog tables. So these are just examples. So we have a table name user catalog, which basically contain basic data about each table. You can try to view this if, in your database. And then user objects, which contains data about each object, the function, the procedures, the indexes, triggers, decision, and so on. So this table contains the time created, the last time change for each object. Okay, so it's very detailed. And then we have user tables, user tab columns, and user views. Okay, so you can check on this one. This is an example of how you can access the Oracle metadata. So you can use this one, this DESC. This one should be described. Am I correct? Describe the full name. So DESC is short form for the command. Can anyone help me? Is it describe? Describe ba kan Ian? Is it DESC? So yeah, it should be describe, but you can still can use it when you just type DESC. Okay, so that's why I want you to do the practical one exercise, also the homework, so that you can be familiar with all these SQL commands. Okay, so I think that's all for today. Still have more time, so I want you to go back to your practical one. I want you, those who have not done it yet, please do the practical one now. You still have time. Hold on, practical one, you should be submitting your practical one homework. Okay, so you just provide you the scripts and also screenshot of output. Okay, so for the automating scripts, I think I already provide you with the script, right? So you just copy from there, or you just type in your SQL Plus and run the scripts. Okay, so any question? So far so good. Okay, so you need to try to do the practical one, yeah, because it's related to your practical two homework. Okay, so please let me know if you still have problem with your SQL, if you with your Oracle database, the Express Edition. Let me know if you have not installed it yet in your machine. Please let me know. Don't keep quiet, yeah. I've looked through your um before I let you go do the practical, I've checked your timetable. Is it okay for us to replace this class or this lecture class for next week? Hold on, next week is holiday, second of 2nd of February, change to 11 of February, the following week. The following week. Is it okay? Can you check your schedule? 11 of February, Friday. It's after our practical session. The following week. Hold on, let me type in. Sorry. Hold on. Alana. Oh, that's good. Okay. The time is 12 p.m. 12 to 2 p.m. Is it okay with everyone? The lecture for 2nd of February we changed to you only free or you have another class. And if you have 3:30, I have another class with RSD1. You have class at this time, Ka, Ivan? To 12 to 2 p.m. Oh, I see. In that case, tapi sambung terus. I'll find another slot again. I'll get back to you. Okay. So for the replacement class, I have class that Ivan I have class with RSD1 at 3 p.m. 3 p.m. Katu. Yeah, I'll check again the schedule. Okay. So now we have finished the lecture for part one. So don't left the meet session. But I want you to use this time to go look see your practical one. See, try to do it. If you have problem, you can always ask me. You can give me screenshot. You can ask me personally if you don't want to ask in the group. And if you have problem, let me know. Okay. So I let you do the practical now, and you leave the session this session at 10:50. Okay. Thank you, everyone.